Hello students, in the last video we have seen the course preview and the overall introduction about the civil engineering. In this video we will be starting the unit 1. In unit 1 we are having introduction to civil engineering, materials, bricks, composition, classifications, properties, uses, then stone, its classification, quarrying, dressing, properties and uses, then timber, properties, uses, then plywood, then cement and concrete, then finally steel. So in the last two topics we will be having the advancements in concrete such as pre-stressed concrete and prefabricated concrete. So for your understanding, uh, the wordings which are highlighted in blue indicates the different materials that we are going to learn in this particular unit. So that is nothing but starting from brick, then stone, then timber, then plywood, then cement and concrete, then finally steel. So if you take 1 2 3 4 5, some sort of new materials we are going to learn in this particular unit. Before getting into this, I would like to mention that so you should have first, so what is mean by material and what is mean by component, because as we have discussed in the previous video, I have mentioned that materials is in the sense of micro perspective and components is in the sense of macro perspective. So what is micro and macro and what is the example for that? So it is so simple. You just take your pen. So whatever pen it may be an ink oriented or microtic oriented or ballpoint oriented, whatever it may be, just take a pen. So what are all the components you see in the single pen? So the body portion, that is one which contains the ink inside, right? So that is the one component, and at the top of that body component you will be having the nib, right? So through which the ink flows into the surface. So that is the second component. Then finally you are having a lid for the pen. So that is the third component. So in this, what is the material you will say? What is the material is being used, whether the component of the body number one and the nib number two and the lid number three. So all these three components have been made with different materials. So can you able to understand now? So if you take a lid for the example, that is made up of a plastic or some steel or some any metal sheet, so depending upon the different type of the pen. And if you see the inside of the body of that pen, there is an ink. So that is a different material, that is mean, that is being manufactured with the composition of different coloring agents, right? So that is how you should differentiate the material from the component. Now come into the civil engineering perspective. Just look around you. You will have a number of walls, right? So you are having a roof above your head and you are sitting or you are standing or you are lying on a floor right now. So all these things what you are being surrounded right now is a component of a building, right? So each component may be in a microscopic scale made up of different sort of materials. So in this unit we are going to see in that microscopic view of different materials only. For example, take a wall. So any wall you just take which you are looking right now around you. So those walls are made up of primarily with bricks. So it's not only the bricks are being stacked one over another, the wall is made. It's not that, right? So to make them attached together, we need cement. So we need other certain sort of ingredients also. That so in that level only we are going to see in this particular unit the materials, right? So the first ever material we will be seeing is the bricks. So bricks is obtained by molding good clay into a block. So understand, the raw material for making a brick is clay, which is dried and then burnt. So two process are there. You have to mold the clay into a brick mold, then you have to dry it, then finally you have to burn it. So this is the oldest building block to replace stone. So you just understand, stone was the earliest material which was preferred earlier than your brick. Once the uh, invention of a brick, people have started replacing the stones with the help of bricks. So manufacture of brick started with hand molding, sun drying and burning in clamps. So the last sentence indicates the conventional manufacturing process of a brick, clay brick, right? So manufacture of brick started with hand molding, sun drying, which means open yard drying, and finally burning in clamps. And of course, if you see the pictures you are having in this particular slide, looks gives different shapes and dimensions of a brick. Both are made from the same raw material called clay, but still and the look and appearance differs. So what are they? We will be seeing and we will be indicating them in the in upcoming slides. So first, composition of bricks. So what is the raw material? Clay. So what are all the requirements? Required elements should be present in that clay. So that's what we are having here. The first one is alumina, then silica, then lime, and certain oxides, iron oxide and magnesium oxides. So alumina uh, is being the chief constituent of the clay. So we are needing and totally 20 to 30 percentage of alumina in a good brick. So this imparts plasticity to the earth. So if you see this particular statement, you can able to split into different components. So the first one is what they are telling, it's a chief constituent, very much important element of the clay. And then how much percentage it's constitute, then finally what role it plays in the manufacturing of brick. So this is how you should read this particular slide. So alumina is an important constituent, then it presents for 20 to 30 percentage. And what is the role of the alumina in clay? It provides the plasticity to the earth. So what is mean by plasticity? Simply you can tell blendability. So you can make the clay molded into some containers or some molds or like that, right? We will be seeing. Then the second one is silica. So it exists in a free or combined form. So we have here that normal sand soil having the chemical name called silica, and it may be present over there in the form of silicates combined with sodium or potassium or like that. So a good brick here should contain 50 to 60 percentage of silica. So if you see alumina, even though it's a very important chief constituent, it needs only up to 20 to 30 percentage. But in case of silica, we need it up to 50 to 60 percentage. The presence of silica prevents cracking, shrinkage, and warping of raw bricks. It imparts uniform shape to the bricks. The durability depends on proper proportion of silica. So like the same way, what is the role of the silica here? It plays actually a more number of roles than alumina. So if you see, the presence of silica prevents cracking, shrinkage, and warping. So three different phenomena they are telling. Cracking in the sense, of course, we know if the mass of the brick doesn't have the enough amount of silica, it may not have that uniform structure. So when we are subjecting the mass of that clay into the process of making brick, there is nothing but that molding, drying, and burning. During the drying process, due to the insufficient presence of silica, the cracking may happen. Once the cracks are developed severely during the drying process itself, then once you subject the same cracked dried bricks into the burning chamber, it will not give you a proper output. So automatically your output will be a deficient quality one. Then what is shrinkage? Then what they are telling, silica prevents shrinkage also. So what is that shrinkage? Shrinkage is nothing but the loss of moisture content from the surface of the drying brick. So as we have told, and the process of manufacturing is molding, drying and burning. So during the second stage, drying, so drying is nothing but losing moisture content, but still the loss of moisture content from the surface level, from the inner mass level, differs due to the extensive loss of moisture content at the surface. So due to that, what happens, mild hair cracks are forming onto the surface of the brick. So that mild hair crack is called shrinkage. So right, so to avoid that shrinkage, we should have enough amount of silica that is being mentioned. So, right, and warping of raw bricks. So what is mean by that warping? So warping is nothing but you would have seen this phenomena with respect to a timber or any wooden related slates or plates, plywood sheets. Have you seen? If you are putting a wooden sheet over the outdoor for which is subjected under varying temperature for a very long time, it would get folded up together. It would get folded up. Uh, uh, right? So we may search it about this. What is mean by warping? So brick clay is plastic due to presence of alumina. This plasticity ensures that bricks can molded. An excess amount of alumina in clay may cause the bricks to shrink, warp, or crack on drying and burning as any other cementing material. So here in this we cannot able to get a proper you know proper view of. Let me show warping alone. No, yes. So this is how you could be able to understand. So warping is nothing but the surface, the mass of the brick would get folded up like this. So if it doesn't have enough amount of your required silica, so that's what I wanted to convey, right? So what are the roles of silica? So it prevents cracking, shrinkage and warping of bricks. So it imparts uniform shape to the bricks. So that is the major role of silica in the clay, which is used for making bricks. Then third one is lime. So lime, up to 5 percentage of is desirable in good brick earth. Brick earth is nothing but the clay, right? So what is the amount they require in the clay? Lime should be present up to 5 percentage. What is the role it does? It prevents shrinkage, the same role in the raw bricks. Sand alone is infusible, so you should understand the role much more clearly here. If you are using only the silica, it cannot infuse your the mass together, but it fuses at clean temperature due to the presence of lime. Bricks may melt and lose their shape due to excess lime content. So what they are telling, they are giving the clear idea about the requirement of lime in the clay and what role it does and what will happen if the lime content excess the given amount. So what they are telling, 5 percentage of lime is desirable in good brick here and it prevents the shrinkage as we have told. So lime is using to infuse all the mass of the brick into a single mass as a final output during the clean temperature while the burning is happening. We will see it in a later stage. So what is the criteria? So brick may melt and lose their shape due to excess lime content. So that is the thing. And finally, iron oxide and magnesium oxide is the reason for color. Both of them should be in a very minor range, 5 or 6 percentage for iron oxide, and 2 to 3 percentage of your magnesia.